Well, in the previous class, we studied about Lasso and ridge regression and that are the regularization techniques. Now, we are going to study normal equation. Okay, so, okay, here normal equation. Normal equation in linear regression. Okay, a normal equation is an analytical approach. Fine. So, what we are going to do in this approach? What formula we want to derive in this approach? Here, we will represent your cost function in matrix format, and the formula which we are going to derive, that will come by using matrix operations only. Okay, the cost function, as you know, for linear regression is summation yp minus y ka whole square by n. Sometimes it has been written like this: 1 upon 2m summation yp minus y ka whole square. See, this 2m, it's n equal to 2m. For simplicity, we are taking. Okay, don't think that I have changed the formula or something else. No. For simplicity, for simple calculations, this is how we can also write. Okay, fine. So, what is this normal equation and how we are going to derive the normal equation? I am sharing my entire screen, and as you paid attention in the previous derivation also, kindly do the same here. So, normal equation is an analytical approach to linear regression with least square cost function. Obviously, what I have mentioned here is least square cost function only. We call it as OLS, ordinary least square. Okay, why least? Obviously, now we want error to be minimum. Okay, so it should be least only and square. So yp minus y is an error. We are taking square of the error. We want it to be least. So least square error, that we call as an MSC, mean square error. Okay. However, in this normal equation, we want to derive using analytical technique. As I told, matrix. Okay, fine. So, how to proceed for it? And what is the normal equation? Here, you can see normal equation. It is given as x transpose x transpose x का inverse dot x transpose y dot x transpose y, that is theta equal to. And what is theta and what other terms are? See, theta is an hypothesis parameter. that define it the best. That's what we did in our previous derivation also. Theta is a parameter, na? It is saying about beta naught and beta 1 only. But now in this equation, it is representing beta naught and beta 1 as theta. Okay, so it is hypothesis parameter. That defines it is the best parameter. We do identify the best parameter only, which should be put in the equation to identify the unknown values. X is input and Y is output. That's it. Okay, so how we write the equation for linear regression? Y equal to beta naught plus beta 1 x1 plus beta 2 x2 and so on. Let us suppose I write like this: beta naught dot 1 plus beta naught beta 1 x1 plus beta 2 x2 and so on. Let me write like this: beta naught x naught plus beta 1 x1 plus beta 2 x2 and so on, where x naught is equal to 1. Okay, just to make a pattern, I'm writing it in this way. Now here, instead of beta naught, since they are representing with theta, so I can write it like this: y equal to theta naught x naught plus theta 1 x1 plus theta 2 x2 plus theta 3 x3 and so on up to theta n x की power n, not x की power n, it will be xn. Okay, don't take it wrong, it is xn, not x की power n. Theta n and xn, that is the nth feature. Okay, now what you can see here is we can understand that this product, sum of the product, we can achieve this sum of the product. Okay, we can achieve how? If I do write like this: theta naught theta 1 theta 2 up to theta n x naught x1 x2 and xn in matrix format. Let me have a dot product. So you very well know theta naught x naught plus theta 1 x1 plus theta 2 x2 plus and so on. This is how we can get the entire answer, this equation. So we can write it in this notation. Okay, and I can turn this thing in this way: y equal to, okay, let's take theta is the entire vector. This entire vector is theta and this entire vector is x. So theta is coefficient, x is input. Okay, got it. So I can write like this: y equal to theta transpose x. See, anyone you have to take the transpose. Okay, anyone you have to take a transpose. So if I'm saying that this is x, so this will be theta transpose. If you are saying this alignment is x, so this is opposite alignment. So you can write it as theta transpose. So y equal to theta transpose x. This is what I'm getting. Is it clear or not? Till here. What I explained, is it clear or not? How I made this matrix. Okay, tell me. I hope it is now. Okay. So this is why. Then it is saying that according to your MSC, according to this, your MSC, we can also represent it in the same form. How? It has written like this 1 upon 2m h theta xi minus yi ka square. Again, this is yp only, this is y only. Instead of yp, it is writing h theta xi, and this is y, and this is 1 upon 2m. I already told you. For simplification, now we can write it like this. Okay, so it's just a cost function only. What we do right for linear regression. Only the terms changed. So yes, I can write it here. Fine. So it's like 1 upon 2m. That's what it is saying for j theta. J theta equal to 1 upon 2m summation h theta x I minus y I का whole square. How it is writing this thing? Okay, now you can understand it very easily. What is this I? See, let us suppose if this is your data. Okay, this is your data. This is actual. This is predicted. So this is zeroth row. This is one row. This is second row. I represents row only. Okay, so it is writing yp minus y. So with yp, it wrote it as h theta x I. That means the output of predicted output of first row, and yi means the output of the first row. This row. So this minus this cos square, then this minus this cos square. That's why we are taking summation. So you have already studied when we consider row, then it is loss function, and when we consider entire, then it is called as cost function. Okay, fine. So that's what it means. Fine. Again, I am writing the formula, that is j theta is equal to 1 upon 2m summation h theta x minus y का whole square, predicted minus actual का whole square. This what I'm writing. Then what it does is, here you can see, here it converted again back into this format. It's saying that okay, you are writing it as h theta xi and yi. Okay, so h theta x0, that means the first row. H theta x1, second row. This is y0, that means the output of first row. This is output of second row. This is the prediction for third row. See, remember, our indexing starts from 0. Okay, so I am talking according to, I'm writing here according to that. 0 means first row, this is second row, this is third row. Don't consider them as x to the power 0, x to the power 1, x to the power 2. No, they are not power, they are just a representation. So h theta x2 represents the prediction in the third row. Y2 is the actual output in the third row. I have shown you here in the data set. So same what you have to understand. And dot 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 up to h theta x ki power n means xn. That means the prediction at the nth row. This is yn, actual at the nth row. Okay, fine. So what we are doing? Subtracting. So that's what they have done. Subtract. Okay, subtract predicted minus actual. This is prediction, YP, and this is actual. Okay, then what it did here, it again wrote the same thing. Okay, that is h theta x0, h theta x1 up to h theta xn minus this will be y. That is the actual output. This will be y. Okay, and then what it did? See, this will be y. Now, one thing I want to tell you, we already identified that this is theta transpose x. So h theta can be replaced by theta transpose x. है ना? Understand this thing. Theta transpose x. This is what I shown you initially. So the substitution has been done. So instead of h theta x0, it wrote like theta transpose x0. You can see theta transpose x0, then theta transpose x1, and so on. So theta transpose x1 and theta transpose xn minus y. Okay, and then it expanded this representation. How it expanded? See, it expanded like this: theta 0, theta 1, theta n. This is 0th row. Okay, all are like this 0th row, and the values of the features present in the 0th row, x0, x1 up to xn. That's how it expanded. Okay, so theta 0, that is your first coefficient, second coefficient, and nth coefficient. These are for 0, 0, 0 means first row. That's what we write now. That's what we do. If I talk about my data, like this is my data, or if you want me, I can make it again. Just understand. Okay, just understand it. This is your x0, this is your x1, this is your x2, this is your x4. This is row number Okay, first row I'm writing it as zeroth row. So what it is writing, theta 0, theta 0, okay, huh, theta 0, then 0 x 0 plus, okay, because it is opening, it is expanding the entire stuff. So here theta transpose x0, theta transpose x1, and so on, we did perform the expansion. Okay, and from here you can see this is the entry for zeroth, that is the first row. 0 0 0 means the first row. X0, x1, xn are the features which are present in the first row. So these are the features. Okay, x0, x1, x2, x3, these are the features present in the first row. And then we are having this second row, I am saying it as 1. So next will be what? Same thing, theta 0, theta 1, theta n, but now it will be 1 1 1. That means now you are dealing with the first row, and here you are dealing with the mth row. Okay, so you did expanded this thing. Okay, and x transpose, theta transpose, sorry. So theta transpose, there is a multiplication happened. What was theta transpose? Theta transpose was theta naught, theta 1, okay, theta 1, theta 2, theta 3, up to theta m. Then you are having multiplication with x0. Then again theta naught, theta 1, theta 2, theta 3, up to theta m, multiplication with x1. Then again theta 0, theta 1, theta 2, theta 3, theta m, multiplication with x2, and so on. So this thing is been performed, and then after performance, theta, okay, what you took after performance, what you took? x0, x1, xn. Okay, so theta 0, 0 x 0. Okay, theta 0, x 0. Fine. Then what happened? Theta 1, 0 x1. Okay, now then theta 0, 1 x 0. Okay, theta 0. Okay, theta 0, 1 x 0, that means first row, first feature, and theta 0 is as the coefficient of that. Okay, so I just gave a rough idea here that there is an expansion happened, and with this expansion you are writing it in this particular way. Okay, coefficient multiplied by its feature, and these 0 1 are the row values. Okay, fine. And then the next thing is, we are getting, okay, what is this? What is this? X theta minus x theta minus y. What is this? See, let me tell you. You have written the cost function j theta as 1 upon 2m summation of h theta x I minus yi. Later on, you have written it as theta transpose xi minus yi. Okay, take the square, yi ka square. That's what you have written. Now, if I do consider only this term, let me just pick up this thing. Okay, just forget about the rest. It is theta transpose x I minus yi. Okay, ignore the rest. Theta transpose x minus y. Okay, it's a square actually. It's square. Okay, fine. Now, how it got this thing? X theta minus y transpose dot x theta minus y. How it got this thing? See, there is a property of, okay, this will be a matrix we have seen. So theta transpose x minus y is a matrix. There is a property of matrix. If I say matrix square if is equal to matrix ka transpose into matrix. This is a property of matrix. Remember, the square of a matrix is equal to matrix transpose multiplied by matrix itself. This is a property. So here, if I say here that, okay, this is a matrix, theta transpose x minus y is a matrix, then theta transpose x minus y square can be written as theta transpose x minus y ka transpose dot theta transpose x dot y. It can be written like this because matrix square is equal to matrix ka transpose dot matrix. This is how we can write it. Okay, what they are mentioning here, x theta minus y. Here also they are mentioning x theta minus y. No, they are writing this term in form of x theta minus y transpose dot x theta dot minus y. That's what they are writing. This is how they are representing. Now, what could be a reason for its representation? What could be the way they are representing it? Why? Are any or property been mentioned here? Do we have any other property mentioned of matrix? What could be a reason that we are writing here x theta minus y? If I do check, if I do check, okay, if I do check this thing like this, okay, where we have explored our formula. So it is According to the representation, according to this representation, it is mentioning it. According to this representation, it is mentioning it. Like x theta minus y ka whole square can be written as x theta minus y ka transpose dot x theta minus y. That's what it is mentioning. Okay, just taking into consideration of the one which we have mentioned here. According to this, okay, fine. Now, when we got this as an equation, what is the possibility? What is the possibility? What else we can do with this? See, let me write it again. X theta minus y ka transpose dot x theta minus y. I can take transpose inside. So it will be x theta transpose minus y transpose dot x theta minus y. Okay, let me tell you, A minus B transpose is equal to A transpose minus B transpose. This is possible. Okay, you can take transpose inside. There is one more thing. There is a property. If I do write AB transpose, this is equal to B transpose A transpose. This is a property of matrix again. So here I can write x theta transpose is equal to theta transpose x transpose minus y transpose dot x theta minus y. This is what we can write. Okay, and then we can perform cross multiplication here. No, not cross multiplication, we can multiply the brackets. Okay, so this x theta can be multiplied by these. So theta transpose x transpose dot x theta, and this x theta can be multiplied here y transpose x theta. Okay, and then y can be multiplied with this minus theta transpose x transpose y and minus y transpose y. This is how we can perform. This is what I can write. Okay. Now, what can be done next? Here, okay, y transpose y. That can be y square, possibly. Okay. That means if y is a matrix, then so its square will be transposed into its own value. So this could be y square. Anything else? I do have x transpose x also. I am having theta transpose theta. So I need to take something like combination. However, I have some different idea. I need to prove that normal equation, and to prove that normal equation we need to thoroughly understand the terms. Okay. And this y transpose x theta minus theta transpose x transpose y, I can do something with that. What it is? See, here the terms like y transpose x theta is a scalar term. It's a scalar quantity. Why? Because y is a vector with dimension m cross 1. Okay, m rows, one column. Obviously, output जो है, output is m rows one column. X is a matrix of input feature, that is m cross m n. That means m rows and n columns. Okay, so this is what my matrix X is, and theta is parameter vector, that is n cross 1. So if we multiply, that means if we multiply m cross 1 into m cross n into n cross 1, so what we are getting? This is n cross n. The answer will be m cross 1. Okay, here the answer will be m cross 1. Okay, so okay, this is y transpose. So y transpose will be 1 cross m. Okay, so take the transpose. So m cross n into n cross 1 will be m cross 1. And this is m cross 1, that is why its transpose will be 1 cross m. So 1 cross m into m cross 1, so m is again same. The output will be 1 cross 1. So 1 cross 1 is a scalar value. That means only one value we are getting. So obviously it's a scalar quantity. Okay, so the answer is 1 cross 1 matrix. That is a scalar. So it is taking it. Okay, so this is a scalar value. Similarly, here also we are going to get something same. What is theta? Theta transpose. Theta is, how much is theta? Just now we have seen. What is theta value? The theta is n cross 1. Na? So theta transpose will be 1 cross n. Okay. Then your next uh, x transpose will be n cross m. Okay. So you can write x transpose will be n cross m. And you are having y. Y is m cross 1. Okay. So you are writing theta transpose, x transpose, y. So it will be, okay, this is 1 cross 1 cross n. This will be n cross m. So n and are same. So you are getting the answer is 1 cross m. And then y is m cross 1. So m cross 1. So this will be over. I will be getting 1 cross 1. So this is also the same. That means point is clear. The terms, this one and this one are same. So instead of writing these two like separated, I can do one thing. Theta transpose x theta minus 2 times of y transpose x theta I can write. This is something which I believe we can check in the original. They are writing it as x transpose y. Okay, yes, so that's what I have written. No, it's taking this one, x transpose y. Okay, so just take it as like that only. X transpose y 2 times. Okay, because this is also scalar, this is also scalar. That will be the twice of scalar quantity. So I am taking x transpose y. That's what I am taking. Okay, fine. So understand. Why it happened? Because of the resolutions, the dimensions. Okay, I can write it as x transpose y theta. Okay, here it is here it is y transpose x theta, and there it is theta transpose x transpose y. So it's better to write it as 2 times of x transpose y theta. That's what we can write for them. X transpose, the dimension will be transpose, na, n cross m. For y, the dimension will be m cross 1, and theta, the dimension will be n cross 1. So m cross 1, this will be over. I am getting n cross 1 here, and here I am getting n cross 1, and here it is n cross 1, and what it is, theta, n cross 1, something like that. Hmm. Okay, so n cross 1, n cross 1, it is twice. So it will be n cross 1 ka something, whatever be the matrix, uska square we are getting. So we have to do actually the differentiation. This is the cost function. We'll be doing the differentiation ahead. Okay, so right now, just by seeing the values of the dimensions of a matrix, we are saying that it is a scalar representation. So y transpose x theta is a scalar quantity, and the same thing is with this one also. It is also a scalar quantity. Both of them are the scalar quantity. So I am replacing it with this 2 times of x transpose y theta, and rest is same, minus y transpose y, let it be. Okay, just okay, don't consider this one, just what I explained till here only. Then the next thing is I, okay, theta transpose theta, let's have the combination of it, theta transpose theta. So x transpose x theta transpose theta is theta square minus 2 x transpose y theta minus y transpose y, let it be. This is the value of your j theta, cost function. To have a minimum cost function, we have to differentiate it with theta. Okay, that's what we have to do. Differentiate it with theta. So if I differentiate, x transpose x will be constant. So x transpose x will come out. Theta square differentiation is 2 theta. Here it is minus 2 x transpose y. Its differentiation will be 1. Theta differentiation will be 1. And y transpose y, it is constant, so its differentiation will be 0. So ultimately I am getting here it as 2 x transpose x theta minus 2 x transpose y. That's what I'm getting. Let me check whether I am correct or not. Let me check. That's what I'm getting after differentiation. Okay. And then we have to equate it to 0. So this will be equated to 0. 2 x transpose x theta minus 2 y sorry, what it is, x transpose y, 2 x transpose y equal to 0. Okay, do one thing. You can take 2x transpose x theta equal to 2x transpose y. That means take on this end. ओके, उसको राइट हैंड साइड पर करें, 2 से 2 कैंसिल करें, देन यू आर गेटिंग x ट्रांसपोज x थीटा इक्वल टू x ट्रांसपोज y. ओके, एंड देन डू वन थिंग, मैं इसी के इनवर्स को लेफ्ट हैंड साइड एंड राइट हैंड साइड आई एम गोइंग टू मल्टीप्लाई. सो x ट्रांसपोज x इनवर्स x ट्रांसपोज x theta is equal to x transpose x inverse into x transpose y. So I am multiplying x transpose x inverse and x transpose x inverse on both the sides. And when a matrix multiplied by its inverse, it become epsilon. That means identity. So identity dot theta is equal to x transpose x inverse x transpose y. When I multiply identity with theta, so it will be like this only. Theta is equal to x transpose x inverse x transpose y. Let me check. This is what I need to derive. X transpose x inverse x transpose y. This is normal equation with a minimum cost function. I know that you are been in trouble with some parts of the derivation. Okay, but maths is something which is required in deep consideration, understanding, then only the things can be understood. And here the entire matrix has been used. Okay, so I will re explain it again. Tomorrow I will re explain it. Don't worry. Okay, we have to follow the same approach. That is, your cost function is equal to 1 upon 2m summation of predicted minus actual. And and you know this beta naught plus beta 1 x and all these things. Just convert it into a matrix format. So that is theta transpose x. Theta transpose x. And okay, you have to write predicted minus actual ka whole square. So it wrote it like in this way: matrix ka square is equal to matrix ka transpose into matrix. This is a property. So it wrote like this: x theta minus y ka transpose and x theta minus y. This is what it has written. So x theta, okay, it's a product of x and the coefficients, x and the coefficient, and this is the actual. That's what it has written. And then I took transpose inside and I just solved it. There is one moment where you have to think, that is this one. It's a scalar quantity we are getting, and I replace it with this. Okay, don't worry, I will re-explain it ahead. In my next lecture I will talk something about it, and then I will proceed to logistic regression. Okay, fine. So that's all for today's class. All right, let me stop presenting, let me stop recording.